The James Webb Space Telescope floats nearly 1.5 million kilometers from Earth, protected by its enormous sunshield as it quietly studies the oldest light in the universe. Every observation it makes is a journey into the past. The faint infrared light reaching its mirrors has traveled for billions of years, carrying information from an era when the first galaxies were only beginning to emerge. Among Webb's most fascinating targets are galaxies that formed only a few 100 million years after the Big Bang. These ancient systems appear surprisingly mature, packed with stars and enriched with elements that astronomers did not expect to find so early in cosmic history. By separating their light into detailed spectra, scientists can identify the chemical fingerprints of different elements. One of the biggest surprises has been the detection of oxygen in extremely distant galaxies. Oxygen cannot exist immediately after the Big Bang. It is created inside massive stars and released when those stars explode as supernovae. Finding it so early suggests that several generations of stars had already formed and disappeared in a remarkably short period. This discovery paints a picture of a young universe evolving much faster than earlier models predicted. Giant stars may have ignited almost immediately after the first galaxies appeared, rapidly enriching their surroundings with heavier elements. Those elements later became the raw material for new stars, rocky planets, and eventually the ingredients necessary for life. After exploring the distant universe, Webb also studies objects much closer to our own cosmic neighborhood. Among them are brown dwarfs, mysterious bodies that exist somewhere between planets and stars. They are too small to sustain the nuclear fusion that powers ordinary stars, yet they possess rich and active atmospheres unlike anything scientists once imagined. Webb's infrared instruments have revealed clouds filled with water vapor, methane, and other complex molecules drifting through these strange worlds. Their atmospheres appear dynamic, with powerful storms constantly reshaping their appearance. Some even display glowing aurora-like emissions, suggesting strong magnetic fields interacting with charged particles. These observations raise intriguing questions. In certain systems, unusual atmospheric behavior could even hint at the presence of unseen companions whose gravitational or magnetic influence subtly affects the brown dwarf. Instead of detecting those hidden objects directly, astronomers study the clues they leave behind. The telescope has also examined planetary systems that look nothing like our own. Some giant exoplanets travel on highly elongated or tilted orbits, evidence that their histories were shaped by violent gravitational encounters. A close passage with another massive planet or the influence of a distant companion star may have dramatically altered their paths billions of years ago. Elsewhere, Webb has captured evidence of giant planets slowly spiraling toward their parent stars. As these worlds move inward, tidal forces heat their atmospheres and gradually strip away gas into space. Over immense spans of time, such planets may eventually disappear entirely, consumed by the stars they once orbited. These dramatic events remind us that planetary systems are constantly changing. Some planets collide. Others are thrown into interstellar space. Many survive for billions of years, while others meet violent endings long before their stars fade away. When astronomers compare discoveries from distant galaxies, nearby brown dwarfs, and evolving planetary systems, a remarkable picture begins to emerge. The universe is not a quiet place frozen in time. It is constantly transforming through gravity, radiation, collisions, and the birth and death of stars. Webb has also observed enormous disks of gas, dust, and ice surrounding young stars. Within these swirling structures, tiny grains gradually stick together, forming larger bodies over millions of years. Some eventually become planets, while others remain as asteroids, comets, or scattered debris. Each observation adds another chapter to the story of cosmic evolution. Every spectrum contains clues about temperature, chemistry, motion, and age. By carefully analyzing those signals, astronomers reconstruct events that occurred billions of years before Earth even existed. Perhaps the greatest lesson from Webb is that destruction and creation are deeply connected. Stars that explode scatter the heavy elements needed for future generations of stars and planets. Galactic collisions trigger new waves of star formation. Even worlds that are torn apart contribute material that may one day become part of entirely new planetary systems. Our own existence depends on this endless cycle. The oxygen we breathe, the calcium in our bones, and the iron at the center of our planet were all forged inside ancient stars that disappeared long before the sun was born. As Webb continues collecting ancient light from the edge of the observable universe, every new image reminds us that the cosmos is still revealing its secrets. Some discoveries confirm long-standing theories, while others force scientists to rethink how galaxies, stars, and planets formed during the universe's earliest moments. The deeper we look into space, the more we realize that the universe is richer, more dynamic, and more mysterious than anyone once imagined. And with every new observation, humanity takes another small step toward understanding the remarkable story of our cosmic origins.